Hello guys, so today we are going to see how to solve a problem in Ansys Workbench of a rectangular hollow cross section. This is the problem. The total length of the problem is 500 mm. The cross section, if you see, the W1 and W2 are same. It is square cross section, that is 100 mm. With the T, it is 10 mm. Force, it is actually a cantilever beam, so the force on one side it is 10,000 Newton and other side fixed. The material which we are going to use is titanium alloy, and we have to find the total displacement and the maximum stress generated. So open your workbench, select static structural, go to engineering data, click on engineering data. So by default the material is structural steel, but what material we are going to use is titanium alloy. So now go to engineering data sources, select on general materials, titanium alloy, click plus, so it will be added to your library. So close this thing. Now go to geometry. We are going to generate the geometry in design modeler. Select the view, go to sketch, select the line, units we are going to select millimeter. Now go to dimension, general, 500, total. Now go to modeling, concept, line from sketches, go to this plus sign, select sketch 1 and click apply. After applying, click on generate. So one part, one body. Now go to concept, cross section, rectangular tube. So this is W2, W1, this T, this is the T. W1 is equal to, if you see, that is 100 mm, W1 and W2, and T is equal to 10 mm. 100, 100, 10 mm, 10. So after giving the, here go again to modeling. In modeling, select on the plus sign, select line body, and cross section, select rectangular tube. So the cross section will be added. So now close this window. If you see, there will be a tick. Now go to model. Now as we have selected the material as titanium alloy, so we have to attach this material to this geometry, to this body. So go to model, go to geometry, select the line body. If you see the material assigned, that is structural steel, that is by default. Click on structural steel, click on the arrow and select titanium alloy. Now go to mesh, click on generate mesh. Mesh will be generated. Now go to static structure, insert, fix support, click on fix support. Now select vertex node, click on vertex node and select the first point. Select this point and click on apply. So yeah, applied. Now go to we have to apply the force. Right click on static structural, insert force. So again click on this thing and click on the other head, click apply. Now the defined by components, y component, that is minus 10. If you see the force, that is minus 10,000 Newton in the negative y direction. Select minus 10,000. There it is, minus 10,000. Go to solution, right click, insert deformation total, right click, beam tool, solution, right, solve. If we get solved, so if everything works fine, we will see the green ticks. Now if you want to see the total deformation, just click on it. So total deformation, the total value is 0.969114 mm. Now go to beam tool, in that select the direct stresses, minimum stresses and the maximum stresses. This is what we want, that is 50.813 MPa. So we can also see the animation, or we can see the report. In report we can see all the values. See the object and its dimensions, the material which we have selected, machine information, analysis. Everything will be generated. Total deformation. So this is it for today. Thank you for watching. Please like and subscribe the channel. Thank you.